before, it's really the same loop over and over again. I'm going to do reset. What I'm going to do is going to define a function. And let me repeat this. In Sage, in the past, I've always declared my variables, but in Sage, X is an automatic variable. All right, so I'm going to just not define it. But if you don't feel safe about that, what do? Define it as a variable. That's up to you. You don't have to if you're using the letter X. Okay, what am I going to do now? Type the function in, as we've done before. I know it's rather repetitive, and that's going to be x cubed. Seems like Wells really likes those cubic problems. And I think the reason for that, they didn't have a digital computer. And I'm sorry, 2 times. I got to pay attention here, don't I? X squared minus 5 times x minus 7. And I'll hit the return. And I made a mistake. Now, someone says, how do you know you made a mistake? It says syntax error. So I have to see what I did, and I see it now. I got to just use the up arrow to get the function back, and I see what I did over there. What's in between there? It should be a plus sign. Hit return. I did pretty good there. So what is it? X cubed plus 2x squared minus 5x minus 7. Then I'm going to do df. That's another function. It's arbitrary by the name, by the way, we call it anything we want. And that's going to be assigned the derivative of f of x with respect to x. All right, to get this, I'm going to define Newton's method, and Newton's method is a function now, and that function can be defined as x minus f of x divided by df of x. All right, I got this. And now I got to make an initial guess. And so I'm going to say, I still want to graph it, all right? So plot, P-L-O-T, f of x, and let's see what happens. And I see the picture, but it's not the picture I wanted. So, and that happens a lot of times when you're using software. It's not the image you want. So what I'm going to do is I'm going to do that again, but I got to do an x min, x max now. So I'm going to do x min equals, I don't know, minus 4, and an x max to be 5. Let's see what the picture looks like, and that's a better picture. Now, I want to make sure you understand you're asked to find the root between minus 2 and minus 3, and it says near minus 3. So I got an issue over here. It's over here somewhere. So what I'm going to do, I'm going to change the plotting view, and I want to change the plot between minus 3 and minus 2 now. Okay, I see that over here. And by the way, looking at it, I got a pretty good approximation here. I know it's about minus 2.9. All right, I know that about minus 2.9. So I'm going to close this out, and I'm going to say about minus 2.9. X naught is about minus 2.9. All right, now again, I want to repeat this. They're telling me between minus 2 and minus 3, but near minus 3. And certainly minus 2.9 is near minus 3. They're being kind of kind about it. All right, what am I going to do now? I want another guess, and that guess is going to be called x1. Now, if this is the exact root, like minus 2.9 makes that thing go to 0, this thing would say the next guess would be minus 2.9, which is no change. Unlikely, by the way, because we did look at the graph before, and it's not exactly minus 2.9. What is this going to be assigned? Newton's method evaluated at x0. But what I want to do, I want to display x1. So I'm going to put that down. I want to see if there's been a change. And there has been. Now it's really minus 2.89. Within precision, though, it's about minus 2.9 still. Let's now do x2. What's that going to be? Newton's method evaluated at x1. And I want to display x2. Well, another little tiny change. Let's keep going. Let's do x3 now. That's going to be Newton's method evaluated at x2. And I want to display x3. And let's see if there's been a change. There's been a change. I'm going to keep going. I want to do x4 now. And x4 is going to be assigned Newton's method at x3. And what do you want to do? You want to display x4 now. And what do you get? Wow, no change. So let's take a look at the code. I'm sorry, not the code, but the output. They write the numbers down. Their guess was minus 2.8. My guess was minus 2.9. But I want to claim over here, it's going to go to that number over here. And this is the number it's going towards. I see that right over here. I also go through Wells's version of Newton's method, and I put that down for you as well. If you look at the SAGE code at the end of the section, I also tell you how to do that using Wells's technique using SAGE. Thank you.